this is really wordy. But as you're reading, remember, I'm always trying to have you synthesize and simplify things. As I know now, yesterday you guys can draw your ionic structures. We actually transfer the electrons, we do the brackets. We're doing covalent today. They look different. They actually have a couple more steps to them. B, very first step here, is going to count valence electrons. So that's what it says there. I'm going to make an abbreviation for this, okay? S, skeleton. We're going to draw a skeleton structure. And in that skeleton structure, we have to choose a central atom. And that's going to either be carbon, the singleton that exists, which will, this will make more sense when we start drawing, or just the largest atom, which we can do our atomic radius little trend trick for that. So we count our valence electrons, we draw a skeleton. Now the skeleton structure, after we've selected the central atom, we're just going to now bond atoms to the central with lines. I'm just going to put lines there. So that's what it means. Bond all atoms to the central atom with a shared pair of electrons. E. We're going to add electrons until octet. Everybody needs octet, except for who?
Noble gases.
Hydrogen, and well, noble gases already have octet, right? But hydrogen is okay with how many? Two. We call that the what rule? Duet rule. So I'm just going to put duet in here, and I think you guys will know what that means. We're going to give everybody octet. And that's either with a bonded pair or with a lone pair of electrons. I'm going to put P here to say pair. I'll explain singleton in a second. We might need a pair of electrons. It only occurs occasionally, but we might have to do that. And in R, we're going to review it. Review and recount. We're going to make sure that we counted the electrons at the beginning and at the end to make sure we haven't put too many electrons or too few electrons on our structure, because there should be a correlation between the V and the R. All right, so I selected to abbreviate this way because this means something. What's VSEPR?
It's the law.
It's the theory, right? Valence, shell, electron, pair, repulsion theory. Okay, so if you can remember that, then you can remember your steps. Now, there are a couple more steps here, and I will be referencing them throughout the rest of the day. So if you'd like, you can take a picture of that if you want to. I'm only going to use these occasionally, okay? So I'm just going to make a couple notes to myself. So these are just extra thoughts. If you have more, you have to add them to the central atom. If you have too many for your electrons for your structure, you can add them to the central atom. And if you need to make double bonds or triple bonds, you can, but we won't immediately do that. That's kind of the last resort. So that's going to be on my question of pair of electrons, question mark. This is where we'll be including double and triple bonds as needed. Okay, so we're going to use this step-by-step process. We're going to go through a couple. I'll set you guys free to build. Okay, I will put it back up there as needed. All right, so your first step. Do you see your structure, NH3? All right, so NH3, follow along with me. NH3 is my structure I have to build. First step, what's it say, Matt? First step. On the instructions you just wrote down. Count total valence electrons, right? So nitrogen is in what group? Everybody pull it up your table and look with me. Nitrogen is in what group? Loud and proud. Fifth group. Okay, so it's in the fifth group. So remember, group equals valence electrons, right? So it's in the fifth group. So nitrogen being the fifth group has 5 valence electrons. Added to 3 hydrogens. What group is hydrogen in? 1. So how many does it have? 1. But there are 3 of them, so there are 3 valence electrons coming from the 3 hydrogens. So we did nitrogen plus 3 hydrogens. Nitrogen is 5 valence electrons. Each of the valences from hydrogen here gives me a total of what? 8 valence electrons. Okay, check. I have done the first step. Now I have to make a what? Skeleton with whom in the middle? Do I have carbon? No. Okay, so the singleton. Who's the singleton? Who do I have a 1 of?
Nitrogen.
Nitrogen. So nitrogen is going to be my central atom in the middle, and I'm going to append, because it's a single, I don't only have one of them. I have 3 of the hydrogens. And then I'm just going to attach with a bonded pair. So let's write out here, skeleton structure, 2 central atoms, bond atoms to central atom with lines. But what do these lines mean? How many? 2. Okay, so note to self, line equals 2 electrons. Okay, so I've got 3 lines to attach my 3 hydrogens. Okay? 3 of those are taken care of. E, add electrons until octet. Does nitrogen have octet yet? No, but I've got 2, 4, 6, right? So I'm going to add something to this to make it octet. Do I want to add a bonded pair or an electron lone pair? Make a choice.
Lone pair.
Lone pair, because I don't have anything else to attach to it. The lines are mainly for attaching things. The dots are just to say I have 2 extra lone pairs, or 2 extra electrons sitting on top. So this is a lone pair. These are bonded pairs because they're bonding something to it. How many electrons are on nitrogen? Say again? 8, okay. So how many around hydrogen? 2. This one? 2. This one? 2. So is everybody happy? Yes. Duet has been met for hydrogen. Octet has been met for nitrogen. So basically I'm skipping this pair things. I don't need it right now. But I'm reviewing it. How many electrons do I have total? 2, 4, 6, 8. How many was that to have? 8. Check. That's the structure. But as you practice, you get your flow. Okay? So I want you guys to look at the chart in front of you. There's a chart here. We're going to determine the shape of it based on how many legs it has and the lone pair. So when I say legs, what I'm actually talking about is something called ligand. Think of ligand as like a leg. How many legs or attachments are on nitrogen? 3. 1, and I'm actually going to make this clear. Here's 1, here's 2, here's 3. So there are 3 ligands, and how many lone pair are on the central atom? How many lone pair? So the pair itself is 1 pair. So there's 1 lone pair there. So what is the shape of that according to your chart? Look at the shape according to your chart. That is a trigonal pyramid, right? Trigonal, but trigonal pyramid. All right, so on my 2D shape on the board here, it looks like a little angel with a halo. Doesn't really look like a pyramid, right? But this is a 2D structure. I can't draw 3D. We have to kind of look at these in 2 different ways. So you have a kit in front of you, next to you with a partner. Choose the blue one for nitrogen. These are my little chemistry Legos. Blue one for nitrogen. Single, the stubby bonds. The stubby ones are the single bonds. Short stubby bonds. Blue one is nitrogen, short stubby bonds. Hydrogens are white.
Wait, so the lines are just one, but 3 of them. A little stubby one?
Yep, because that means 2 electrons.
No, get the little white one.
The white ones are hydrogens. And hold it like really flat on your hand when you're done so I can see it. Hold it high. Hold it up, yep. I don't know the words of that song. That's what it sounds like. Okay, so can everybody see there's a gap underneath your hand? What's it kind of supposed to look like? It's a, come on. It's a pyramid, right? And look at the bottom of your base. Be quiet if you're talking to your neighbor. Look at the base. What's the shape of the base? It's a triangle pyramid. Trigonal pyramidal. Okay? So that's what this looks like. Now, what's on top? And this is just, you got to watch where my hands are down here. What's on top right here? Well, some of you guys have a hole there, but look on the structure you've drawn. What's up here? A lone pair. Okay, so the lone pair is made of 2 electrons. Make your hand really big. Okay? This is a lone pair. It is huge, and it's got a lot of negative charge. Now, this negative charge is kind of right next to these little gray bonds, right? What are these gray bonds made of? Electrons. What do electrons do to electrons? They repel. So basically what these lone pairs are doing is they're pushing down on these lone pairs and they're pushing them away. They're repelling them, which is why it has a pyramid shape. If it weren't, it would just be a little flat surface, right? If that lone pair was in there, it would be flat, and we would call that trigonal planar, like a plane, like a flat plane. But because there's a lone pair, it pushes it away and makes it a pyramid. Okay, so we're going to work with these some more. Put these down for now. And I want you guys to do CCL4. CCL4. Do not build until I see the structure.
I ain't done math in a minute. I think that's 20, right? Alright. I ain't done math in a minute. 32, right?
Do you not need a calculator? Don't know. Use your head.
Yeah.
What? You gotta add 2 dots.
7 times 4 equals 28.
You gotta add 2
Add 2
dots.
and that's 30 and then add another 2.
All right, back up to me. 3, 2, 1. Eyes up here. Eyes up here. All right, so do not build yet. I need to make sure you're good. So hands off the Legos or I have to take them from here. Thanks. So you guys took your 4 for your carbon valence electrons, 4 chlorines with 7 valence electrons. Who got 32 valence electrons? Okay, you put your carbon in the central because that's your skeleton. You've added your chlorines. Who made it this far? Okay, what did you do next, Garrett? Okay, so we went to the E step. E, make everybody have octet. Who's the only one with octet so far?
Carbon.
Carbon, so I need to add octet by doing 2, 4, 6, 8.
Oh.
2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So now everybody has octet. So I've just given them all octet nonchalantly. I'm not really counting electrons right now. But now I'm like, okay, everybody's got octet. Now I need to review it. You have to go through these steps or you will stop short. So I'm trying to save you from yourselves. So now count by 8s for me. 8, 16, 24, 32. Okay, so check. I've gotten my 32. So now I need to now go to the shape. Parker, how many ligands are on my central atom of carbon? 4 ligands. So you have to look at your central and you say there's 1, 2, 3, 4 ligands. There's 4 legs. Who wants to tell me how many lone pair there are on the carbon? Ramina? 0 lone pairs on the carbon. So 0 lone pairs on carbon. Everybody, look at the shape.
8.
Tetrahedral. Like a tetrahedron. 1 second. Like a tetrahedron from geometry. That's what it's resembling. Build it. Now, build it. Carbon is black. Chlorines are green. Carbon is black. Chlorines are green.
Wait, we did the. Wait, do we do this?
Wait, I have a question.
The killer. I gave it the right size.
I always say that.
No, look.
Alright, hold it in the air so I can see. Alright, so for you.
Yeah.
So you got it. I'm just gonna hold it from one side. I want you guys to approximate. If you were to look at my carbon and chlorine little bond, if you were to look up here, this kind of looks like a right angle, right?
Yeah.
Kind of, right? So it looks like it's 90 degrees. 2D structures don't do it justice. Look at yours, and let's approximate what that bond angle is.
75.
Hold up. Is it more or less than 90?
More.
It's more than 90. Can't be 75. It's more than 90.
110.
That's 100, 104.5.
Oh, dang.
I know, you approximated, but it's memorized. Okay, so what we now know is that our 2D structures, you will assume many things from them, but you cannot assume all things from them. You have to build them or spatially visualize them to get the whole picture. Okay, so don't just assume that you're right because you're like, oh, I drew it straight, so it must be linear. Or I drew it like a T, so it must be a T shape. No, you've got to access the resources I've given you. Okay, deassemble those for a minute. Let's do another one.
So just be on the test.
You will have access to that chart. Yeah. Okay. If you need it, sometimes I do, sometimes I don't. Kind of depends. Okay. Draw this one.
God dang, you gotta use force to get these out of here. That's so too.
Wait, how do you get 8 to 8 to 12 plus 8?
Yes, it is.
You guys can do math.
No, I can't. Look at this. There it is. So we got about 6, right?
5. I think it's easy to draw them. Yeah. Keep going. I want to see what you got.
That's not right.
You have all your steps. Yeah, that's accurate.
I did something wrong. Yeah, but that wouldn't count.
Alright, back to me in 3, 2,
I'm thinking.
1. Ready? Back to me. Go. Okay, so I know you guys got here, but then you didn't go through your steps. You're letting yourself go because you're not going through your steps, okay? So many of you guys just were like, all right, octet, yeah, oxygen and sulfur and oxygen. You're like, yeah, everybody octet. You get octet, you get octet, you get octet, okay? And then you double checked your count, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20? What? So how can you go to the east or the peace? Because I spit out my lunch, I'm sorry. I was trying to eat like my okay, so I need to now consider, do I need a pair of electrons? The answer is yes. And this is where you have to consider, can I do a double or triple bond? Yes, you can. So basically right now you've given sulfur a lone pair and oxygen. But do they both need their own separate lone pair?
No.
What could they do? They could share, right? So they could say, all right, sulfur, greedy. No, you don't get your own pair. And oxygen, greedy. No, you don't get your own. You guys can just share. So I took out 4 and I put 2 back. So essentially, how many did I subtract? 2 from 20, which gives me 18. So I chose the right side. You could have easily just as well just chosen the left side, so it looked like this instead.
Since it didn't look that one, I couldn't do with any of the other ones.
So if I did that twice, here, there's a good question. Listen, I could do this on this side or on this side, but I couldn't do it twice because then I'd be down to 16 electrons and it wouldn't be correct. So I just chose one side. So either this is correct or this is correct, but you can't do electron double bonds on both sides. So build this now. But let me, before you build, actually, now I can tell you. The flexible bonds, the long ones, they can be used to make double bonds and triple bonds. So your sulfur is yellow. The double bond will be 2 little holes filled. The oxygen is red, and so your double bond will be on one side, but you flex them. You actually pinch them together. Like this. Double bond.
Oh, that's why it's bent.
That's why it's flexible, yeah. The other one is a single bond. Single is that short, stubby one.
We did both.
Pew.
Well, somebody help him out there. Okay. All right, so look back up here for me. Look back up here. Ethan, tell me how many ligands, and everybody needs to write this down with me. Ethan, tell me how many ligands sulfur has. How many attachments? 2. Okay, this is where everybody messes up. So if you're not listening, you're going to be one of those people. There's only 1 attachment on this side, and though it's a double bond, it doesn't mean there's 2 attachments. It just means it's a more strong bond between sulfur and oxygen on this side. There's still only 1 attachment on this side. So overall, how many ligands? 2 ligands, and everybody, how many lone pairs on the central atom? How many? 1. Just making sure you're with me. So there's 1 lone pair. So total that up, what's our geometry?
3.
Bet you have 2 ligands and 1 lone pair. Look at your shape. It's bent, right? Isn't this bent? Now, if you just look at the structure, the 2D structure on the board, you guys are going to be like, oh yeah, that's linear. Yeah, it's a straight line. She drew like a straight line. It must be linear. Don't always trust your drawings for the shapes. You have to build or visualize. Okay, so that's bent. Go ahead and do this one now.
Oh, I cannot do that.
Oh yeah.
There has to be. Can you?
You have to add a central atom.
Yeah.
Quick note. Everybody write this down written down in black. Okay, so we said it's the octet rule, right? But it's not the octet law. So if we break the law, we're not going to get locked up, okay? So there are occasionally, about 50% of the time, some atoms will expand octet, meaning they are allowed to have more than octet. Phosphorus, sulfur, and chlorine, and down on the periodic table, those are the ones that can expand octet. So if you have to, you may, but we try not to. We don't have to. So I'm thinking right now, you guys are thinking, oh crap, I got to expand octet, don't I? Okay. So you got your structure.
No.
Okay. Well, do you have your valence electrons?
Yeah.
Okay. How many valence electrons did you get? 40. So you took your what is that? 5 from phosphorus, plus 5 times 7 valence electrons from chlorine, so that's 40 valence electrons, right? All right, Josh, what'd you put in the middle?
Put in the middle.
Phosphorus, which is, we can either choose carbon or singleton. Alex, what do you think I should do with those 5 chlorines?
Why not do the 4? I want to do the 5th one.
So that's why I made this disclaimer. So normally we would just put 4 in there and be like, okay, well, what do I do? The 5th one can also bond to the central atom. So we'll make 5 attachments to the central atom. So chlorine, 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 chlorine. Okay? All right, Nathan. I've got to give octet to who right now? All the chlorines, right? So dot them up. Dot them up. Okay. Chlorine has octet. Chlorine, all the chlorines have octet, right, Hunter? How many does phosphorus have? 10. Can phosphorus expand octet? Yes, it is in the little PSCL, which is in the right side of the periodic table, and down. They can expand, so they're good. Hunter, how many total electrons do I have on my structure? Say 40. So I've gone through the R part. I've reviewed it now, because that's 8, 16, 24, 32, 40. I have 40. Now you have to build, because this structure is not on your sheet. We're going to figure it out by looking at it. The beige one is the phosphorus one. Beige one is phosphorus.
Wait, what color is this?
Green. So I'm not saying it's a fashion statement, okay?
What's the color?
Beige, green.
And blue. I just bought the color blue.
I appreciate your contributions in class.
Huh?
Green.
They're not the same size.
Don't let the beads fall away. Get it?
L.
All right, everybody hold it up by one end with the 3 in the middle. The 3 should be in the middle.
So smooth. It's only 4.
Okay, so guys, eyes up. I have to give some of these kits to Mr. Macumber soon, so I've got to get you through this. We only have so many, so we have to share. Okay, so you got it held up, right? Now, I know you can't really tell the shape as is, but let me draw it first on here, and let's see if we can figure it out. So I've kind of drawn the 3 top, middle, and the bottom in the same plane. You can see one's kind of going to the back into the board, and one's coming out of the board. So if I draw this now, do you see the triangle in the middle? So you see the triangle in the middle, right? Do you see the pyramid on top? Yes? Do you see the pyramid on bottom? Okay, so it's trigonal. Look in the middle. Trigonal, pyramid, pyramid, right? So looking up at me. Trigonal, pyramid, pyramid. That's called bipyramidal. Trigonal, bipyramidal. Trigonal, bipyramidal. You gotta be able to see it. You see it.
Say it.
Write that down. All right, help the person next to you see if they can't. Trigonal, bipyramidal. You can't turn it like this. It's got to be upright. The 3 in the middle. Because there's a triangle in the middle.
Have you ever heard that song?
All right, I'm moving on. Be a symbol.
Oh,
Draw nitrogen.
I got it.
Draw nitrogen.
I like that song.
Stand up.
Mom told me to rock.
He's not really listening. Find it. Find it. Get it. Go get it.
Go get it. Me too.
Guys,
10 down to electrons.
Yeah, I do that all the time.
So
guys, you can count. I'm not gonna come around and just tell you yes or no. You can go back and count. If there's not 10, then it's wrong.
you rock.
You can count your balance like that. Did you go through your steps?
Here we go. I did it. I'm all done. I was really good.
I think I did it. Is this right?
I'm so
Yeah, so your bond is on yourself. Your bond
Your bond with yourself.
like this. It's sharing the top.
Right, how can she write better than me with her left hand? That's pretty.
Here you go.
Yeah.
Right? Oh, that's what I was right.
All right, pause. 3, 2, 1. Who drew this? Who drew this?
I just
Put
did.
your hands down. Put your hands down. This is wrong. Okay. So here's your thought process, guys. Shh. Here's your thought process. You probably did this first. You're like, yeah, all right. 2, 4, 6, 8, 10, 12, 14. 14? Oh my gosh, I can only have 10. So then what did you erase? Okay, so I'm going to erase the 2 lone pairs here and here. And you said, no, nitrogen, you don't get your own. You have to do what?
Okay.
Share. And then you're like, all right, yeah. 2, 4, 6, 8, 10, 12. What? I still have 12. So what do you have to do again?
Yeah.
Delete. Okay, I'm going to do the sides just because oh gosh, I'm doing it with my left hand. Peanut butter and jelly in the other. Okay. So I got, is that it?
Got add
Okay.
bond.
So I had to now make them share, right? So I've got 3 shared pairs, 2 lone pairs. That's 10. Build it.
Oh. I think it's a blue one. It's a blue one. You gotta get Here we go. There we go. 3 flat small 2 Now you put it together. Get it.
Hold it up so I can see it. Okay, everybody hold it up. It looks like this is like an hourglass. Alright, back to me in 3, 2, 1. Eyes over here. Alright, if you had to make an artificial line between this nitrogen and this nitrogen, and then you had to call it a shape, what do you think that shape is? Do not make up some random line. Say again? Linear. This thing's linear. There's only one way to connect 2 atoms, and it's with a line. Don't get crafty on me. This is linear. Write down the shape for me.
Linear.
Okay, linear, huh? Somebody's like hourglass, which it does look like that, but it's not the shape. Alright, I've got one more for you, okay? Back to me.
It is not.
CH3Cl. And I'm gonna have you guys draw this on this, okay? Because this is gonna be what we are pretty much finishing the rest of the top here. CH3Cl.
Okay, so smooth.
I'm not sure that's enough. I will try.
You can burn it.
Pass these back, pass these back. Extras, leave them back. Leave them back.
What are we trying to draw with? Electron got structure.
Alright, I'm gonna do this with you guys, okay? I got the whole first part of it with you. Leave it back there. You're good. Alright, pay attention because this is what we are gonna be finishing today and tomorrow. We're gonna draw them. We're gonna understand what they look like, and then we will finish building them tomorrow because I need them all drawn before you can build. So I can't fit everything in my little boxes, so if you can't, you get the whole back of your sheet to work with here. So here we go. We're first going to just straight up draw, okay? So in terms of CH3Cl, carbon has how many valence?
6.
No, that's its atomic. That's its
4.
atomic. 4, you're looking at group number, okay? 4 valence electrons from carbon, plus 3 hydrogens, each with what? 1 valence electron. Oops. Plus, how many from chlorine? 7, because it's in group 7. Total that up. 14. You're doing this with me. I'm basically doing the first one with you guys, okay? Make sure you're with me. 14 valence electrons. Cool. All right, so now what? Why C? Okay, C wants to be in the middle always because it is it's great at bonding 4 times because it has 4 valence electrons. So if it gets another 4, it has 8 octet, okay? So carbon goes in the middle, and then what do you want to do?
Draw the line.
Draw the lines. What am I adding to it? 3 hydrogens. And I'm just doing it as symmetrically as I can, and then one of them will be chlorine because that's the other one. I got 3 hydrogens and 1 chlorine. Okay, who's already good? Hydrogen and carbon, right? Carbon has 2, 4, 6, 8. Good. Hydrogen's got duet.
Yeah.
Who's not good? Chlorine. What's it need?
6 little dots.
6 more, right? So now it has octet, right? So check, we've counted valence. Check, we've put skeleton with the appropriate number of electrons. Everybody's got octet. Now what do I have to do?
Count.
Count them again. 2, 4, 6, 8, 10, 12, 14. Score! We got 14. All right. Before I move on, build this. Build it. Carbon's black. Hydrogen is white, chlorine is green.
Black.
Alright, and because I have to give these to Mr. Maycomber, close up the box and put it back in the lab station real fast for me. We'll put these back shortly. Close the box, the whole box. Keep your little structure out. Keep your structure out. And let's focus back here.
Hey, guess what? We got ours back.
Stay focused. Shh. Okay, so we're going to finish this chart together, but you got to pay attention. I'm going to wait for the whole crew. You with me? Okay. So we've got now the structure, but we need to understand everything about it. So I'm going back to the bond polarity section. What bonds do you see here? Hunter, tell me one bond you see here. Between who and who? Carbon and chlorine. Everybody look on your electronegativity sheet. This is what we did at the very beginning of class. We're kind of wrapping it back in. Carbon has a 2.1 electronegativity. Chlorine has a 3.0. Okay, what's the difference?
0.9.
0.9, or is it 3.5? Oh, sorry. I heard we're doing chlorine. Oh, I'm sorry. Hydrogen's 2.1. That's what I'm thinking. Okay, now I see your confusion. Here, 2.5 and 3.0. Difference is 0.5. Okay, and I know this is slightly different on some of your papers, but it's right on the line between what and what? Polar and nonpolar. It's actually just a teeniest bit of polar, but it's on the line. So I'm going to say this is polar covalent, just a teeny tiny bit. But some of us have the 0.5, some of us have the 0.4, so it's definitely right on the line. All right, so guys, if it's polar covalent, what do I have to draw? What's the line called? Dipole moment, right? I'm always going to draw my dipole moment, especially if I have a polar covalent bond, and I'm going to draw it pointing towards which way? The more electronegative one. So that's chlorine in this case, right? So what I've drawn here, I'm going to replicate that right on top of my image. So I'm going to draw that now right here, just kind of on top of my chlorine to carbon bond, just like so. I'm going to draw a little hash on the side where the carbon is. Okay, so earlier we said the arrow was pointing towards the side that was going to be deemed partially what? The arrow is pointing towards the sides that was going to be deemed partially negative. So this side over here is partially negative, right? So I'm going to kind of do that same thing right here and call this side over here partially negative. And the hash mark was put towards the what? Partially positive, right? So I know that carbon over here is like the partially positive region. I'm going to start really cluttering my image. So I'm just going to draw this one right here because I'll know the other side is partially positive. All right, what's the other bond you see here? Carbon and hydrogen, right? Okay, so this is kind of all going in the bond polarity box. So carbon to hydrogen, what are the numbers for those? 2.5 and 2.1, right? Okay, but who's more, who gets the arrow? Who gets the point of the arrow? Carbon, because it's more electronegative, right? So we're pointing the arrow towards carbon now. Hash mark goes on hydrogen. Arrow gets the more electronegative one gets the arrow. Oh, sorry. And why did I do that? I skipped that step. This difference was what? 0.4 is the difference, and that's right in the polar covalent region. It's kind of right on the line between polar covalent and non-polar covalent, according to the key. So you just have to kind of bear with me now, okay? So our polar covalent, we drew the dipole moment, we've got that there. Now I need to draw that same thing on these bonds. So where do I draw the arrow pointing towards? Towards the center, right? Towards carbon. So I'm going to draw one pointing towards carbon, another pointing towards carbon, and another pointing towards carbon. And if you get this part, this is the more challenging piece of this because you have to do a lot of visualization. So you have a partially what out here? Good, because the carbon is partially negative, so the hydrogen must be the partially positive. So the hydrogen here is partially positive. You with me? Because hydrogen was less electronegative. Same story. Hydrogen was less electronegative, so it's a partially positive. Hydrogen, less electronegative, so we got the partially positive. So all we're doing is looking at the differences in electronegativity, looking and see, does it have a dipole moment? Yes, it does. And we're putting it on our structure now. Okay, hold up your structure. I want you to put your hand, I'm kind of arranging it orienting it the same way up here. I want you to put your hand on the partially positive side. Just a flat hand, okay? This is the partially positive side, right? That's the hydrogen, hydrogen, hydrogen. So over here is the what? Partially negative side. Okay, so as a whole, you guys are telling me this whole side over here is partially positive, and this whole side over here is partially what? Okay, go back to the very first thing we did, and I want you to tell me, is this a polar molecule or a non-polar molecule? Talk to the person. Okay, we'll go ahead. Polar because it has unequal. Okay, I heard both things. It's polar. It's a polar molecule because it has, what two words are you saying? Opposite charges and unequal distribution of charge. If it were equal distribution of charge, I would have positive, 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 positive. If it were positive all the way around, it would be considered non-polar.
Like positive, positive, negative, negative.
This shape will not allow for cancellation. So come back to me. Come back to me. So what I've just done for you is discuss molecular polarity yet again. So let's just say hold your hand on two pieces here, okay? If these two were partially negative and these top two were partially positive, they still wouldn't cancel each other out. Because what has to happen is they have to be directly left and right, like exactly left and right of each other to cancel out like a positive, positive, or negative, negative. So I'm going to show you guys that here if I can. I wasn't going to do this until later, but I'll do this now. So if the geometry, if the geometry does not allow for two opposite ligands to cancel each other out, it's tending to be polar. So the geometry has to allow for two polar or two dipole modes pointing outwards to cancel each other out. So it has to be like that. But because a tetrahedron doesn't allow for it, it's still going to remain polar. We will practice with that a lot more. But what I want you guys to do first is on the sheet that you guys have, this sheet right here, we need to finish filling out these last two pieces, okay? So we have the bond polarity section with me. If you're talking to your neighbor, I need you to stop. Thank you. You have your electron dot structure. What is the shape? Look at the sheet. Make sure everybody's with me. How many ligands does it have? 4 ligands, right? How many lone pair? How many lone pair on the central atom?
0.
0. So what's the shape?
Tetrahedral.
Tetrahedral. Good. So that's the answer to that little box. And then you guys already told me it's what?
It's polar.
It's polar. And this is the section that's a little bit rough, but you guys should be totally good with these first 3 columns. Okay? And then you guys can definitely answer this one too. How many lone pair, or how many lone pair on the central atom? 0. Okay? So I want you now to take some time, go through the ones you feel comfortable with. Not the last one, we haven't learned that yet. I know you're going to be more comfortable with some examples over the others. Work the person next to you and draw. Go through all the structures as you can and draw.
Let's just go in order.
Okay, if you like sketch everything in an electron dot and think of do a better job on the back.
Yeah.
Like that.
No.
You can't look at it going to the
BA in the middle. And then 1 off each other. 1 letter O. With the 6 dots on it. How many does that have? 2. So BA with the 6 dots.
Oh, yeah.
So oxygen would have. Oxygen would be bigger. Wait, who's in the middle? Why would you do this? I think that has 6. Because it already has 6, so that would be way over. I don't Oxygen already got 6.
Disclaimer. Ready? So this is cumulative, right? So if you come to the point where you're like, oh, this is a metal and a non-metal, predict what kind of bond metal form for me.
Ionic.
Ionic. So you know that now. So you are responsible for all the properties of iron, covalent, and metallic. And then you look at the electronegativity. Everybody look at barium and oxygen. On your electronegativity charts, guys. Your electronegativities. So we got 0.09 for barium and what? 0.9 for barium and 3.5. That difference is what? More than 1.69, right? So it's definitely second confirmation, this is ionic. We don't draw ionics like we've been doing today. Remember? What did we do yesterday? We drew them a little differently. If you need to go back and look at your notes for that, we'll do that. But if you can't get it, move on. You got lots of examples to do. Okay? Move on.
who is it? VA? VA 2 plus is 6. I would equal.
But you're missing.